Alright, welcome back. So today let's continue working on Scufris. So for anyone that's new, Scufris is our AI assistant, and how it works is that we basically have an LLM that works as a supervisor, and then we have a bunch of other LLMs and tools, and all of these things form together like a multi-agent system, some nerd stuff, but in the end, the goal would be to ask our Scufris a question. So like what um, is the weather in London. Let's change our city, and then you'll see that Scufris is gonna think for a bit. Then it's gonna give us some tokens. I guess that time that it took a bit, it was actually loading the model, right? And then what happens is that it thinks of what it has to do. It's gonna check for the weather with a knowledge agent, which is another LLM. Then the knowledge agent has a tool for being able to check the weather. So it's gonna make a request to weather.in. It's gonna get some information. It's gonna come up with like a response for Scufris. Scufris is gonna get that response, and it's gonna give us back the response. So yeah, that's kind of the workflow of how this multi-agent system works. And as you can see, right now we only have a CLI tool, but what I would like to be able to do, like the idea is that once you close this thing, the chat history goes away. So you lose the reference to the chat history, right? And that could be a good thing. It depends. But what if you want to have like a window somewhere, or I guess that's how I'm gonna work with it probably. Maybe a window in like the scratchpad. I don't have a scratchpad. I guess I have to figure out how to do that on i3. But let's just say that you have a window that you start and close, right? Or something like that. Or you run a tool with Rofi or something, and you can chat with Scufris, and it remembers what you chat with it about. So to do something like that, we would need something like a server and client approach, where the server runs in the background, similar to how Olama does that. So if you do, I guess we already do Olama serve, right? And we can just do run. And this is the client, and Olama serve is the server. So we want to do something similar, but the difference with Olama is that we also have tools and a bunch of other agents, right? So Olama is just a single LLM. So that's what we want to have, right? So we want to be able to run the server. So it's going to be something like Scufris server, and then we are going to have something like Scufris client that's going to connect to that server. So I think that's what I want to do for today. So let's see. So it's going to be more of a, it's not going to have to do that much with the LLMs or the agents. It's just going to be us implementing. I think I want to do it with Unix sockets because I don't really care uh, about doing it in a web app, although a web app could also be nice. I'm not gonna say it's not, but I think for the start, we can try to have really simple Unix sockets implementation. So sure, let's have something like a server. I think I'm just gonna call it server, right? So this is gonna be the CLI tool that has everything integrated. Or I guess, yeah, kind of, because it creates the context, and in the context we have this guy which writes to the terminal, right? Those tokens that you just saw, it writes them, and then we have the IO part, which is just a for loop where we read stuff, we call to the chat function, and then we print the response. So what we are going to do, right? We should implement a new observer type that's gonna send the messages via the network, but just the socket. And this part is gonna go into the client and we have to handle it somehow. So yeah, let's see how we can do something like that. So for the server, let's start with the server, I guess. So it's gonna be called main.go. I guess we'll start kind of with both of them. We are just going to make progress on them as we see. So for the server, okay, so I guess Golang Unix sockets. Let's see how we can implement really simply. Do we have an example somewhere of like an echo server and the client? I guess this one is good enough, right? So obviously we want to somehow open a Unix socket. So this stuff, we already did something like this a bunch of times in C when we implemented the HTTP server. That's one time when we did it. I guess it's nice to go through the steps again and understand how to do that. And I think Go is kind of an easier language to do that in because it has these Go routines. So yeah, let's go ahead and do that. So it's gonna be different because instead of I don't remember how the sockets are called for networking, but it's a different kind of socket, and instead of a file you put like something else, but whatever. So let's go ahead and start to create these things. So we are still gonna do login whatever. So we want to import networking, and this thing, yeah, so it was TCP, right? For doing the HTTP server. And here we are doing Unix. And obviously I would like to have like a constant variable for the socket path or something. So this thing should be like a variable so that we don't have magic strings. Socket path. Nice. Okay, so do we have listen Unix? It's really interesting. Why do we have this function? What the fuck? This one is so weird. So it has this argument network, but it's forced to be okay, so you can have either Unix or Unix packet. Okay, makes sense because you might want to use one. I don't know what the Unix packet is honestly, but okay, I get why. Fine, whatever. So we could use listen Unix because yeah, I was like, that's weird. Okay, so listen Unix, and for the socket path, that's okay. So maybe it's a different kind of thing here. So it wants a Unix address. What's a Unix address? Okay, whatever. Let's not worry about okay, let's keep it as listen. Whatever. Right, so here I guess it's a string because if you listen on TCP, you provide it with 000, right? So stuff like that. Let's not worry about these things. So we have a listener. Let's call it ln or listener, or maybe even listener. Okay, then obviously we have to check if we have an error, right? And honestly, I think the easiest way to handle errors in the main function is with panic, because if you cannot create a listener, then it doesn't even matter what you do afterwards, so we don't really care. Okay, and after we create a listener, we have to accept connections. And you might remember that I think that for the C project that we had to do two steps in here. It was creating the socket and then binding it. But here you can see it's only one step, which, I mean, fair enough. It makes it a bit easier, but yeah. Okay, then I would say that we want a for loop, just like that, just create a for loop. And now what's interesting is, honestly, I don't really care about multiple connections. I would just want one connection. But if I'm gonna have a window that I'm gonna close and open, then it makes sense to have this for loop, because if I close the connection, then I don't want the server to stop, right? So I want to be able to create new connections. Right? And if we get an error in here, that's kind of interesting. What kind of error would happen? Listener. Because I don't think you want to like panic in the for loop if you get an error. Like you don't want to kill the connection to the other client, so maybe we just want to do something with a logger. So this one does some logging, and then we can have logger slog dot default or something. Logger dot error, why not? And in here they said accept error. Where was this? You know what, let's just put error in here. And oh, I have to do like accept error and then %w, right? And then put the error. Okay, and then maybe continue. Right, and then we have to do something like go echo server. And now I guess this would be like handle connection, and maybe handle new chat. And this could be interesting. Let's implement it as handle a new chat. So if you close the client, it still kind of handles this, it still kind of works the same way that it works now, which maybe is not ideal, but it's fine for the time being. Let's say that when you when you connect to the server, it creates a new chat for you. So that would be the entire thing. Okay, so let's implement the handle connection function. So we're gonna have this kind of function here, handle new chat, and all it has to do is pretty much something similar to what we did in the CLI tool. So let's copy paste this part. So we have this handle new chat, right? And this is kind of everything we have to do. Wait, is it not W? Do I have to do any and then like that? I guess that's fine. Right, so we basically listen on this file, right, for stuff, and then we have an infinite for loop where we handle new connections as they come. And then here we have the connection. There I called it FD, but here it's C, whatever, doesn't matter. So this is the connection. I guess the first step you want to do with a connection is to close it. Do like a defer c.close. That would be the first step. And here this part is interesting. So if we want to handle a new chat, we might want to create a context here, you know, with the observer that we are gonna make. Right, then we create the Scufris like thingy. So the Scufris builder creates all the agents, all the tools and everything, and it returns the supervisor. So all it does is just give us back the main agent that you can chat with. Right, so this guy we are gonna call chat on it. Okay, here we read from stdin, but what do we want to do instead is to read from the connection. Right, so instead of reading from buff.io, we want to read from the connection, just similar to here. So how can we do c dot? We can do c dot read, but something else that I would like to do is Roland Unix socket gob. I would like to define some structures that we can use. Unix socket and code struct or something. How can we send and receive structures? Huh. I thought it's something to do with the gob, that you can create an encoder and decoder on a connection, and then you can actually just read things. So something like new encoder, for instance, and you can provide C, which is a reader. So if you can do dot read on something, it means that it implements the reader interface, right? So or I guess here it's writer, but you can also see dot write. So yeah, so you can create a new encoder that's going to be used to write things to the socket, I guess the connection to the client. So this is going to be our encoder, and we're also going to have the decoder, which is going to be gob.new decoder, and then you pass C. So that way we get an encoder and a decoder. Right. And I guess here you can see that we pass the context to building Scufris, so we need a context. That's why it's kind of, I'd say it's fine right now that when you create a new Scufris, you basically also initialize the history with nothing. So that way I think it's fine. The only problem that we have right now is that it's kind of made so it's used only by one person, because let's say we have something called the image registry, which contains all the images that you send, and this thing is like a global variable at this point. So yeah, right, so you call something like get image and add image, so that's something. But obviously we could see, like, we can say with image registry on the context and add a separate registry. So we could add a separate registry, so it's still fine, still kind of okay to use like this, but yeah, it's a bit weird. Anyway, so I don't know why I did oh, here I created a reader. So here what do we want to do? We don't want to print anything because it's not server's responsibility to print that. It's the client's responsibility. So here we want to read, I guess we kind of want to read a string, but I would also like to make it a structure. So maybe we can have like a shared package where we put networking messages and even the socket path, obviously. And maybe maybe we want to do something like this. So here we have messages from the LLM. It's not the same. So this is gonna be, yes, message kind or something, but it's like a message between the client and the server. Do you want to call it differently? I'm not sure what's gonna be the name of this thing, but we're gonna have stuff like just a prompt. So message prompt, right? When you send just a prompt, maybe something else, but I'm not sure right now. So let's call this one message kind. Message kind. Right, so this is going to be used for networking. And then maybe we want to struct, like type message struct, and I'm pretty sure we have already message struct, right? But this is going to be LLM message and this is going to be like net message, so it's fine to have the same name. I guess that's something pretty nice about Golang, that you always have to put a prefix, right, to types and things, so that's fine. Okay, and here the message is gonna have a message kind, so let's say kind. I'm gonna do this one public because yeah, I want to access it. And maybe a payload, which is gonna be an interface, right? So it's gonna be like an any. I would say interface is the same thing as any. And let's say message kind prompt, because I was thinking maybe I want type message prompt, or maybe it's just payload prompt. This one is going to be a structure, and it's going to have a prompt which is going to be a string. Okay, this can stay message prompt, and yeah, we have the message prompt type, and then we have this structure that's going to fit in here. So I'm pretty sure you have to do something like gob.register, and you want to register a type. Okay, let's search encoding Golang. Maybe we can find some already went on that page at some point. I'm pretty sure you have to register a type so you can use it, especially if it's like this. If you use any here and you want to decode a message, then you want to register the payload prompt, right? So oh, example. Yo, that's pretty nice if they have an example. So here they create a new encoder, new decoder. They encode something, they decode a variable, which is type Q. Like that should be enough, but would be nicer if they had something like something to do with register. Anyway, let's put here inside of register payload prompt. Can I just register records a type? Golang gob register example. I would like to see an example. Okay, so you just put it like that. Interesting. Okay, so, and I saw that they usually do encoder and decoder here, so let's keep it like that. And maybe the register, we want to do it not in handle because that's stupid. We want to do it somewhere here because it's like an initializer, right? We are just initializing something. Obviously, we have to do this one both in the server and in the client, but we'll remember that, don't worry. Always remember things. So here let's do decoder dot decode, and maybe we want a variable m message, and we just want to decode a message. This guy can return an error, so if error is not nil, we want we want to show the error with a logger. You just copy paste it. Decode error. Wait, I want to do it like this. Right, that's something, I guess that's kind of ugly, honestly. But I think that's something you can write. Okay, anyway, so here we basically decode our message. And then what we want to do is a switch on the message kind. And here we should add cases. Whatever, that's fine. I mean, it's not fine to have a panic, but oh, and here I guess I want to return in case. So if you cannot decode the message, I guess you just want to kill the connection. Maybe here I want to say say this kind of thing and then return or something. So we want to show the unexpected message kind, something. Okay, and in case we have a message prompt, we know, I guess we don't really know that, but we are gonna assume that it's a payload prompt in our payload. So we're gonna do something like prompt is equal to message.payload, and we are gonna change it to payload prompt. And I guess we can just take the prompt, right? So we basically got the prompt. Here it's showing some error what it's trying to read. And what we want to do is call Scufris, call chat on it. We get the response. In case Scufris had an error, we are going to call on error, right? So on error is going to be supposed to send this yeah, like on error is going to be supposed to send the error to the client, right? And maybe instead of just printing, what if we had something like obs dot on. So we have a bunch of options: on start, on token, on blah blah. But what if we have something like on chat? And we'll have to add on chat. It's not there yet. I don't really care about it right now. Do I have to call Golang switch? Do I have to call break? I think no. So in Golang it's the other way around, right? So if you have switch, you automatically break, and if you want to fall through, you have to call fall through yourself. I think that's kind of a better approach, honestly. So we have to do something with response. I don't really care about it right now. We'll see what we are gonna do with it. Maybe I want to implement this on chat thingy, but right now, yeah. Okay, and we have the encoder. We are not using it yet, so we are gonna have to see what we can do about it. Obviously, it's gonna be part of the observer, but yeah. So we have to implement a new observer. Okay, so it makes sense, right? We're gonna have here probably something like Unix, or I guess socket. Okay, socket is fine. So we are gonna have socket, and in the socket we are gonna put our things from here. We are gonna put this initialization with register, and that's fine. So new socket observer, and I would say the socket observer needs the encoder, because the socket observer is gonna send messages to the client. That's my idea here. Which I think it's decent. Right? So yeah, the idea with observer is it has those callback functions like on error, on token, and those functions are gonna send messages to the client with the encoder, which I think it's fine. Now the other option, which no, I think this one is a bit better, to be honest. So yeah, because this one, I mean, it's the same thing. I'm still not sure which option I like more, putting stuff in the context or actually sending the dependencies like with dependency injection in the constructor. I'm like, not sure yet which version I like. I've seen kind of that the context option is more Go-like for some reason, not sure why. More used to this approach, but you know, kind of liked the idea of adding things to the context because it's like a bit easier, right? So here you add a new observer, and then what you do with this context, for instance, in the Olama implementation, you have this on start, on end, right? And you pass the context to it, right? And if the context is empty, then this function doesn't do anything. So that's kind of a cool way of saying, okay, if you don't pass an observer, then it's not gonna do anything. So I think that's kind of nice. Okay, anyway. Because otherwise what you would have to do is pass here the observer and then do something like if observer is not null, then you do observer dot on start, right? I guess it would be like o dot. It's like this. So I think it's I don't know, I'm not sure yet. This one makes it a bit more obfuscated, so it's a bit more hard to read, but at the same time it's easier to implement, so I don't know. Anyway, now that we got a bit sidetracked, let's get back to implementing the socket observer. So I guess I'm gonna do that in internal. So let's do socket. And I want to copy paste probably the verbose one. Not sure. Probably I want to paste in the verbose one. So the colors themselves, not sure I need them. So it's gonna be a socket observer. And as I said, I think I want the encoder part of the new. So here we're gonna have the encoder. It's encoding dot shit, no, it's probably gob dot encoder. Right, and this guy is gonna get an encoder, gob dot encoder, socket observer. Right. So if we go back to the server main, curious, so I just want to include socket. New socket observer. And what's the problem? Okay, so the variable is a pointer, so I might want this one to also be a pointer and this one be a pointer. But here it should say that the encoder, or I guess socket observer, does not implement observer, so we have to actually do stuff. So what are we gonna do on start? Not sure yet, so let's just comment out what's not relevant. What are we gonna do on token? Again, not sure yet. On end. On error, that's something we have to deal with. On image, that's also interesting. On tool call, and also maybe I'm just thinking that maybe we'll be able to use this on the server and then the verbose observer on the client somehow, but I don't know yet. Okay, so that's all that we need here. So probably we don't need, I mean, probably we'll need the image registry, but we can just delete these. Okay, so if we think about this, clearly we need a message for each callback, because we are gonna send messages every time, right? So that's gonna be interesting. So let's have a message.go package, and in this message.go I'm gonna copy paste these things. Package socket. So we can just delete this from here. It's gonna complain that, oh, we don't have message, but we have socket message. Right? And thing is that usually you have messages from client to server and messages from server to client, right? And how this works is that the messages that go from client to server are messages that the client can create and the server handles, and the messages from server to client are the messages that the server creates and the client handles. So I think I want to have messages to and messages from or something like that. And right, because yeah, sure, it's gonna be like client message and yeah, why not? So we're gonna have client message, and message kind is still gonna be message kind, an integer, I mean. Hmm. And that wouldn't work. I mean, maybe we can just keep it like this to make things simple, but yeah, sure, why not? We can keep it like this to make things simple. I don't really mind to have a single structure for both of them, but yeah, maybe, you know, if we had better enum capabilities with Go, I would have done it like two different structures, but we don't really care, so we are just gonna keep it like this. Okay, and we might want an init function, like messages, or yeah, message init. So we need to import gob. So here we can say socket dot message init, and I also want to move this socket path. So we're gonna have something like config.go package socket Scufris socket. All right, so here when we go back to main and it complains that it doesn't know about socket path, we're gonna have socket dot socket path. Nice. So now for the socket observer. So as I said, here we want to send some kind of message. So here we have name. So how are we gonna send the messages? Let's take a look at this thing. So here we encode something. I think it's enough to just encode. So encode means send, right? That's pretty nice. Sadly, on start doesn't return an error, so I'm not gonna change it. Okay, anyway, so o.encode, and the encode takes in probably an any, but we want to send a message, right? So I kind of don't want to have, maybe I just want a function new message. Kind is message kind, and payload is any. Right, so it's like, sure, fair enough, we are not really creating a constructor for each type because that's kind of boring, so I'm just gonna do a new message. That should be enough. So here I'm gonna do new message, and the message that we're gonna send is on start. So I'm gonna do here message on start. So let's copy paste message on start, And then for the payload, we actually need type payload on start. It's going to be a structure, and it's going to have a name. Sure, fair enough. So here we're going to say payload on start, and we can pass in the name like that, I guess. Right, and yeah, the sad part with the error is that we don't really handle it, so because I guess I should do error in here, and it is what it is. I have to, even the error can error. That's pretty funny. And then we can fix the thing. So here, for instance, if error is equal to that and error is not null, we just return the error, or I guess error. Should be fine. Yeah, and the other ones already could return an error. Even here. I guess here I can just return that, it doesn't matter. Here as well, just return it. Okay, whatever. So now here, for instance, we can have an error. Let's see, let's think about it. So for instance, I'm using the observer in Olama. Yeah, I mean, let's not care. I don't know. Sure, fair enough. Let's keep it like this. So I would have to change verbose one as well. Like here, just return null. Right. And the other ones, again, I don't think we care that much about it. Okay, whatever. So we just return. If we get a token, we want to send a new message, which is going to be on token. Let's just add them on token, and we just send the token. Right. when we do on end, we send a message with type on end, and the payload is basically nothing. On error, that's interesting. I guess it's just message on error. We just send the error. Why not? And for image, it's kind of interesting because the client doesn't have the image registry. So I need to do something similar to what we did here. But we send the image bytes. Payload on image, nice. And I guess otherwise we return the error. Yeah, and as I said, we still need the registry, we still need probably Scufris and FMT apparently. So we just return the error. What I'm not sure though is, okay, and then on error, is it being called from no, but I guess it's fine because this thing is gonna return an error, and at the point where this error is being handled, we are going to call to on error. All right, so the client is gonna receive the information that the image is not found. Right. Now the only part that's a bit sucky, let's say, is that here we are not making the error into a Scufris error. But doesn't matter. Let's just pretend it doesn't matter. And we can use ChatGPT for that. So yeah. And here at the end we want to put the tool name and the result. So we are gonna have something similar. So it's gonna be it's gonna be message on tool call end, payload on tool call end, and we have to pass tool name and result, hopefully. And here, why not? If we are still doing that, we can just tool name and args. Okay. Oh, so on error, I forgot about something. On error, it should return an error. And now, yeah, it should be happy. It should say that socket observer is actually an observer. So now we just need to implement these messages. So message on token and their types. So can we do something like this? Socket message. So yeah, we want message on token message on end, message on error, message on image, tool call, and message on tool call end. Right, I like how the LSP picks it up almost instantly. So we have payload token. Maybe capitalized. Payload end, which doesn't really have anything. That's nice. Payload on error, which should have an error. Then we have payload on image, and we can say here that it's a image and it's gonna be bytes, or it's base64. Okay, so it's just a string. It's base64 then. That's nice. We don't need that. Null. Okay, and then we have payload tool call. Is a struct. Tool name string, args any, and then we have tool call end with result string. Nice. So result is also any. Nice. So now we don't have any errors left. That's pretty nice, but we have to register these types. So on token, on end, on error, on image, on tool call, and on tool call end. So those should be all of them. Okay, nice. I was pretty sure. Yeah, like error implements error. Nice. Whatever. Again, maybe we want to convert these into my own type of error. It's like agent is gonna call to chat, right? If it has errors, it converts them to Scufris errors. Right. But then llama, if it has an error with on token, it's just returning the error. Yeah, or in tools image, it just returns the error. Okay, fair enough. And then in the main function from here, what we did was just on error. And here it depends in the verbose version on error. Okay, so on error just prints the error. If it's a Scufris error, it prints it nicely, and if it's any kind of another error, it prints it like whatever. Okay, fair enough. So then it's not a problem. Okay, so now at this point we implemented all of these on token, on error, all of them to work with the new socket observer. That's pretty nice. So they should write to the client. but now we have to implement the client. So I guess that's the next part. Okay, so for the client, let's create a client, main.go, and maybe we can use some things from the server. Package client. First of all, we want to initialize our messages. Probably we want to set up a logger for some stuff. Okay. But now the difference is when we create the connection, instead of listen, we want to dial, which is the same thing as I think it was connect in C. I don't remember exactly, but you know, we can implement something like that. Like, you know, sometimes you get the urge to implement networking in C. Okay, so this should connect to the thing, and we can call it like connection. If we get an error, we panic, we defer connection close. So the server should never like close or something. Yeah. Okay, let's defer connection close. Okay, then we go reader. Interesting. So let's see what this thing does, because maybe it's, you know, something that we don't want to do the same. Uh-huh. So it has, okay, again, I don't really want to do it like this, because here you have the reader running in parallel, you know, or I guess it's a go routine. So it's running parallel to this for loop. Right, so what would happen is you send messages and you receive them in parallel. So what I would change is just have a for loop like we did in the original main, so in the Scufris main. So what we are gonna do is just create this bar.io reader from standard input. We can print some stuff. We are gonna read a prompt, right? We are gonna read this prompt. If there's an error, here we can panic because it's the client. Then we need to make a message. So I would say the same way we do it in the server with encoder and decoder, we are gonna do the same here. Right, I mean, sure, we can rename this to C because that's the same way we used it in the server. Anyway, so here instead of directly calling to Scufris chat, we need to send a message. So we are gonna do encoder dot encode socket dot new message, and the message kind is gonna be message prompt, and the payload is gonna be payload prompt with just the prompt, like that. And if we get an error from encoding, we just panic again. Why not? Okay, so we send a message. What don't you like about this? Ah, really? So usually they don't like that. Interesting. But here it was fine. I guess it's because it's internal. Okay, makes sense. Does it make sense? Let's read the warning again. So it was something like struct literal uses unkeyed fields. Okay, so maybe if you import it, you have to use keyed fields, whatever. Okay. And what we need here is to also receive all the messages. So I want it to be blocking though. So how can we do that in a nice way? Because after you send this message, we want to decode messages until you get back a response. Right? So if we check the main from the server, here we did something like decode. Right? I guess again here we can just panic because it's the client. So at this point, you have to somehow handle the messages. I'm thinking if we can do it in a nice way, but I'm not sure. Like maybe with the observer. So I would probably have something like a for loop as well, while we can read stuff, right? Let's take a look at the verbose observer. So verbose observer has this context. Yeah, it's not gonna work really well because it looks at the context. Right, so here you can see kind of where it's kind of meh to use the context because yeah. But okay, anyways, doesn't really matter. We can just pretend that the client works in a different way. So we don't even use the logger. So while we can read messages, we need a switch statement, switch m that kind, right? And let's fill in cases. So we have message on end, on error, image start, prompt, we don't care about prompt, right? And let me just go to the server. Okay. So go back to verbose. Let's copy paste. Let's do on start first. So if you get on start, so I want to copy paste this one and call it like name payload, and then it's payload on start. right? So that's how you get the name, and we print it nicely here. And again, you know, here it doesn't matter, you can use any library you want to print this stuff, but okay. So we get that. We have on token, which is also interesting. Here we need this one. So token payload and token, why not? For on end, we just want to print the line. And another thing that we want to do with on end, not really. We don't have an on end message. So we need a way to signal that we need to close this for loop. We'll do that. Anyway, if we have an error, let's take out the error. Payload on error. So we get some kind of error. Again, here maybe want to have some kind of shared between, like we might want to share somehow these functions and use them inside of here. So maybe we want to implement some kind of a pretty printer or something. So maybe we want to have something like pretty.go package pretty, and then from verbose we might want to copy things. So for instance, this would be function on start, and it gets the name as a string. Right, and then the colors, we just move them. Not sure about the error, but whatever. Then we have on token, which works like this. We have on end, which works like this. So it's basically without the context. We have the error printing, pretty printing, I guess, which should work like this. Pretty printing an error. Then we have the image. This one could be interesting. So in the registry image, we have a type called image registry that we can send. Registry, or I guess R registry dot image registry, and here we can say R dot image registry should have a function. I lowercase them, okay. Why not? Get image ID. Right, so we can still use it. Not okay, then or I guess if it is okay, right? We need to icat the image. So let me just steal this function, icat. Otherwise we return some Scufris error, and that's that. Then we have on tool call and on tool end without context. Without the context. Okay, nice. So now instead of doing all of this stuff, we can just call to pretty printing. So here we can do just return pretty dot on start name, right? That's pretty nice. Pretty on token turn pretty on end. Here it would be pretty dot on error. Now here it's a bit interesting. It's registry dot I guess it's similar to wait image registry. We want function get image registry context, and we want a key image tool registry. When we do, no, we don't really have get tool, whatever. Do we really not have something like that? That's weird. I was in verbose, so we need to do something like get image registry from the context, and we should get back an R. So we should get back image registry or error, right? And we should do something like this. What's the problem? It's just pointing it. Fuck. It's Boolean or something. Whatever. So we can call to get image registry, we get back the registry, and we can just use it. But here, instead of all of that, we can just say return pretty.onImage r image ID. I guess, sure, pointer, why not? So we do that. Here return pretty.onToolCall, tool name and args, and then tool call end with the result. So it's a bit simpler, right? So now if we go to the client main, instead of doing these, we can just say pretty.on end, right? On error pretty.on image. We need to get the error, obviously. Like that. Here we need to get the image, payload on image, and we also need shit, that's the problem. Okay, so on image then it's just gonna take the entire image itself and it's gonna do icat. Okay, makes sense. So inside of verbose for on image, fuck, to do something like this. And I guess then it wasn't even get image. I could have done just get image. Okay, fair enough, whatever. So changing the registry for the image wasn't even needed, from what I can tell, because here it's just getting the image and it's sending the image like base64, so that was fine. Okay, so let's go back to main client. On image, here we can do pretty dot on start, pretty on token, let's say tool call, Alright, so this one is just like that, on tool call end, right? But we still need that extra message for ending stuff. So I want something like message on response. Or I guess message response, that's kind of it. Let's put it first. Right, so these two are the prompt and the response. And let's just copy paste it. Response. So we have that. Okay, if we go back to the main client, if we get case socket.message response, can I do something like loop? Fuck. We want to break the loop, but we also want to print the response. So yeah, response payload response dot response. So something like that, right? So in case we have we finally get the response message, we stop the loop and we go back to reading from the user. I think that's fine. Right, and on the server side, once we finish the chat, right, we want to send back the message. So let's create a new message somehow. So we need to do something like encode. Socket new message, message response, and here we are gonna do response, and the response comes from here. Obviously we can have some kind of error. I don't know if I want to show it like that or like that. Anyways, it's like if you have the error, you anyways go back. Okay. No, I guess, yeah, I want to do a return. I want to close the connection. Failed to encode. Or I guess it's encode error %w slog.any right, just like this one. Didn't even realize that you get there. Yeah, sure, fair enough. So I think that should be it in terms of the server and the client. Okay, so maybe we can just try to run them. Go run, oops, cmd server. I guess I should have printed something, but whatever. Let's develop, go run, and let's run the client. Wait, what? So we have some stuff inside of pretty. Ooh, what? I forgot to remove that. Okay. And we don't need registry. If we type hello, that's kind of ugly for some reason. I wonder why it. Okay. I think I know. I think I copy pasted it wrong. Lol. So inside of pretty, I think I copy pasted on token wrong or something. It's like it's sending on start every time. Okay, maybe I'm displaying it wrong inside of main. So on token, yeah, I should do on token. Right, so now it works as how is the weather in London? Yeah, like maybe I want to show some logging in the server. Not sure why that counts as an error, and the file should be good. Okay, let's see what we can see here. So I guess, you know, everything was done, so all is good. Okay, so if the prompt is empty, I guess that's one of the issues. If the prompt is empty, maybe we should. So if prompt is equal to empty, then maybe we want to just stop, like return or something. And as I said, inside of the server, maybe I want to run it with level debug, right? Maybe I want to run it with level debug so we can see. So, oh, show, that's annoying. And another thing we have to do is delete this file. So we want to do something like io remove delete. That how do you golang delete file? How do you delete the file? OS, oh, it's OS. OS remove socket path. If error is not nil, what am I doing? Panic error. I guess this symbol is the one, the walrus operator, whatever the fuck, is the one that I hate the most in Go. It's like so annoying. Because if you declare, so let's say listener was already declared somewhere, but error wasn't. If I write a line before this line, it's gonna show as an error because, well, error was already declared up top. So that's so annoying. It's like, why doesn't it work with shadowing? I don't know. But anyway, in this case, it wasn't the case, so it's fine. So maybe I want to also display some logging stuff. So like logger dot info started, or I guess listen on %s socket path. Fuck socket. Like, why not? And maybe here logger dot info handle new connection. So at least now we okay. So here it doesn't need that. Whatever, I don't really care about logging. So here if we open this thing and what is the weather in London, it says that that was called, then it generated that response, it called to that tool. So again, now we have this server client architecture, which I think is pretty nice. So if we close that, it's still crashing like that. Don't really care. If we kill it, yeah, well, I don't know, that's not really an error, but who am I to say? So it happened like the code error. Sure, whatever. Okay, so Now I guess for the last part, which is, you know, something unrelated, but yeah, we actually got the thing done, which I think it's pretty nice. But what I would like to do is inside of our Unix flake, I've added this Scufris service, which is a Go application, right? Which we built from CMD service, and it's gonna be called obviously Scufris service. And we also have the Scufris client as an application, right? Then we have our basic CLI tool, doesn't really matter, and we expose these, I guess, packages, right, that you can actually install, which is kind of nice. Then I don't know, this one I copy pasted from ChatGPT, I don't know what it does. Then we have home manager modules, and I guess the default one that you get from this flake lets you enable the Scufris service, and basically the Scufris service creates a systemd user service that runs the Scufris service, which I guess the Scufris service is basically this client, which I mean I called it server in my project, right? So it's gonna run the Scufris service, and it also makes the client as a package, so it's available. So if we are able now to add somehow this flake in the home manager for my thing, we should be able to see these things working like globally somehow. Okay, let me just make feature added server client, but I'm not sure if I want to do that now because it might be kind of boring and annoying to get it working. So, you know, I'm pretty happy with the result of us having the server and then being able to run a client, even though, as I said, if you close the client and you create a new client, it's like creating a new chat, so you still cannot get back an old chat yet, but we'll have to see what we can do about that. But yeah, with, you know, the idea being that maybe we want to let Scufris somehow run things in the background, right, without you having to open the client manually. So that was my initial idea. So we'll see how we can actually do that, because that would be pretty nice. But yeah, anyway, so at this point, yeah, this works just like a server client, which, you know, right now it just enables Scufris when you create a new chat, but we'll see what we can do about that, because as I said, I would like this thing maybe to be in the main function, right? So I think that would be kind of more interesting. So yeah, let's say that we take this stuff, and what if we put it somewhere here, or like here. But see, for that we need this encoder. So we need this part here, but we need to pass the context and Scufris, and then maybe Scufris can be something global, like a global variable. Yeah, why not? Let's make Scufris a global variable. Scufris is gonna be like agent.agent. right? And then here we can actually just call it on Scufris. And here we can say Scufris is equal to okay. So this one wants to be a pointer. Oh, and then the context doesn't need to be global. It can be just I need the context to be global because yeah. Okay, whatever. So ctx context, right? Now I think what's nicer about Golang is that it doesn't have that ownership stuff, so you can do all sorts of crazy stuff with multi-threading. What the fuck, did I press something? Okay. So if we now go run the server, and we also go run the client, is the weather in Paris. Right now it should keep the chat history. So if I close this thing, shit, I should have waited for it to finish, but what about London? It should have the at least my message, I think. So let's see if it figures out what I wanted. First asked about the weather in Paris, right? So now it's gonna ask. Oh, it got both of them. Okay, nice. So see, now it has the history for the entire conversation, even though even if I close the chat. I think that's how I want it to work. So I'd say that's fine. So yeah, I mean, again, I don't want to do a new chat every time. I want it to keep its history, but at some point you also want to kill the, or I guess to reset the history, maybe, if you want to, I don't know, or at least do something with the history so it doesn't grow too much, right? So again, maybe for the time being, yeah, I'm gonna keep it as it creates a new chat every time you open a new chat, and then when you close the chat or something, it saves that history somewhere, or it like makes a summary of the history and it saves it in like a small database. And if you ask about something, it also does retrieval on that old history. Again, I don't know, like we can do a to do here, like let's go back to this one, creating a new chat every time. But what about, oh, so in the builder I'm gonna do something to do, add a chat history tool, maybe in the knowledge, that we can retrieve stuff from, right? So that would be the idea. We should have a tool that does retrieval on the chat histories that we have, right? But we'll need to somehow save those chat histories. But again, I think that's, you know, something that we can do another time. I'm still working on the shell functions right now, so yeah. But I think this one sounds pretty cool to implement. Somehow saving the histories and then being able to retrieve information. And who says that we might even be able to like fabricate histories, like for instance make it believe that it has free will. No, I'm just kidding. But yeah, So yeah, anyway, like this was the entire thing for today. Hopefully it was interesting, and hopefully by the next time I'll have more CLI tools and also be able to actually serve it like when I start up, so like run it from home manager. But yeah, with that being said, I guess that's it for today, so let's see in the next one.